Thank you very much, Subrata. Again, thank you very much for the invitation. I'm very pleased and hugely impressed, I have to say. I was a part of the PET school, and the level of knowledge of your young colleagues in this school was actually beyond any impression I had so far. I sometimes participate in other schools, and the level of knowledge is just amazing. So my sincere congratulations. So after this beautiful lecture from Bangladesh, I'm a little bit embarrassed to talk, to be honest with you. Those are my conflicts of interest. I will speak a little bit of the background, why I believe it's important what we are doing, and a little bit about the frustrations that we see. And then I will go through technology slowly. First, I would like to actually share with you that being rich and beautiful may not be enough to do a good job in childhood onset diabetes. This is a report from the Rich and Beautiful. Here we have Sweden, and have Germany and Austria and Denmark and Norway and England and the United States. And I'm not sure what Wales is doing here, but anyway, so Wales is also there. And this is my little country. So we are neither rich nor beautiful. So it may be other things actually that you approach Sweden, despite the fact that we are a little bit far away geographically. And we will discuss how to do this. The second message is from the United States. So this is 10 years back, and this is actually the current cohort. As you can see, in the best centers in the United States, including the Joslin Center and Yale, and centers that participate type 1 exchange, actually, the control deteriorated. As you can see, it's worse, despite the fact that they use technology, they use sensors, they use pumps. So another very, very strong message that there is a problem. And if you look at this very recent, actually, report here from Diabetes Care, this is a field study of type 1 diabetes, and this is what I previously showed you, the type 1 exchange. You see that the field study actually is even worse. And in our age group, adolescent age group, if you want, they are above 9% with glycosylated hemoglobin, which for our environment in Europe would be regarded as a complete disaster. And this is the latest data. So it's a huge problem that we see. The good news from this study is that the severe hypo actually does not increase with a decreased A1C. So the DCCT paradigm is finally over. It's simply not true. So as you can see, the high severe hypo starts with high glycosylated hemoglobin, which was demonstrated in several trials. And even if you analyze here that you compare A1C below 7 and A1C between 7 and 9, as you can see, there is no difference in severe hypo. So it's safe to go below 7. Whereas severe hypo increase if you go above 9. So these frustrations actually are almost everywhere, but not everywhere. I will give you a good example from Scotland. This is the Scottish registry over the years. They didn't do anything altogether, but here you see the pediatric part of the Scottish registry. And they really made a huge improvement, a very significant improvement, and this is due to be part of the international community and new guidelines, and of course my sincere congratulations to the Scottish colleagues. Probably what's not being in focus enough is the brain. And here is the first report of the DirectNet group from the United States, published some years ago now. The first paper who said that the brain damage demonstrated on functional MRI is not related to hypoglycemia. You see here who experienced episodes of severe hypo or seizures compared to those who did not. So the damage they saw was not related to severe hypo. And this was at that time really a very big surprise, and nobody really believed it in the United States. But they showed actually that the damage is related to glucose standard deviation. And the follow-up study of this same group 1.5 years later, published last year, actually demonstrated that actually this is related to hyperglycemia significantly, so to high blood glucose. So this again was against the sacrilegious belief on the opposite side. This is true for the adult population as well, just a nice study comparing the adults cognitive impairment, type 1 and type 2 diabetes, compared to healthy controls. And interestingly, in this type 2 study, including 11,000 patients actually, non-severe hypoglycemia was protective for cognitive. So those that had non-severe hypos did better on cognitive tests as compared to those who didn't. And severe hypo was not significantly associated with cognitive impairment. Finally, I would like to share with you data on healthy population. This CARDIA study was done by cardiologists. It's a big study performed in Germany 30 years ago. And they looked 20-year-old young adults that did not have diabetes. They are completely healthy. Yet after 30 years, when they were 50, they realized that actually glucose variability was associated with worse cognitive processing, attention, and memory in midlife. And please remember, these are healthy people, so they could not have hypoglycemia. The only variability that was possible was hyperglycemia. And to my utmost surprise, a couple weeks ago, actually, this paper was published. The same group, and they realized that they did MRI on these people, and they realized not only cognitive, but also hippocampus MRI. This is hippocampus fractional anisotropy, as you can see, is significantly reduced in relation to visit-to-visit standard deviation. And as also is the volume. So the hippocampal volume also is significantly related here to standard deviation. Same is true for the white matter. As you can see here, the white matter volume is significantly reduced in relation to glucose variability. Again, healthy population without diabetes, so no way of having hypoglycemia. The only thing they said was how they had was hyper. And finally, a confirmation study, also very recent from the United Kingdom. Here, 2 studies altogether, actually more than 15,000 people with and without diabetes. And if you look to no diabetes people, actually, standard deviation of A1C, again, was very nicely related to the memory score and executive function test. So again, healthy population could not have hypoglycemia. It's related to hyperglycemia, and hyperglycemia actually causes cognitive impairment and brain damage. And this is the first very important message I want to convey. The role of CGM, as you know now, it's a grade A evidence, and we'll discuss this also later, in the standards of care, very recent from July of this year by the ADA. So it's beyond discussion that the CGM helps. The first study we did actually in the years 2005 was published 2006, the first randomized control trial published, and the success was so big actually that nobody really believed it. It took the JDRF trial that was published 2 years later in the New England Journal that people started to believe. They got the same result, that this really works. And it was a special, focus on children, because children on average did not benefit. But then when they did the per protocol analysis, of course, children did even better, actually, than the adult population. But the message was you have to wear the sensor, you have to use the sensor in order to be successful. Big trials were done in the last couple of years on MDI. This is actually the Diamond trial. As you can see, the use of sensor was extremely high, above 90%. More than 6 days a week, above 90% of people, close to 100. And you need to do this, otherwise it doesn't work. And yes, A1C after 12 and after 24 months was significantly reduced, as was time in range significantly improved. It went only up to 50%. Please remember this number. So CGM with MDI, up to 50% time in range. Hypoglycemia was significantly reduced. So all these important parameters. We did this trial actually years ago in a pump population, and we chose to use a crossover design. Why? To see whether washout period would actually destroy what was achieved. And this is exactly what happened. Look, so when the sensor was on, the A1C decreased in 6 months, but in 4 months of washout, it went exactly back to the start. So there is no memory, there is no carryover actually. You have to use the sensor in order to be successful. And big trials with MDI then confirmed exactly the same. So they did also a crossover design. As you can see, a beautiful decrease in A1C in the first 6 months, but a complete reversal during the washout period. They exactly copied our protocol, and the results are exactly the same as published previously. Hypoglycemia as a focus here. This is the old DCCT that doesn't hold anymore, as I told you. This is the current hypoglycemia level from the JDRF, and this is when you use the sensor. You can see that you can reduce hypoglycemia and move the A1C back from 7 to 5.5 to 6.5 very safely with this technology, with a decrease of severe hypoglycemia. The first trial, actually, again, we published now very, very long time ago in 2011, the first hypo as a primary outcome. We obviously showed a 50% decrease in time span in hypoglycemia, and this was nicely replicated in this GOLD trial published last year, when the time below 70% as well as time below 53% was beautifully reduced by using the sensor. Probably the most important message comes from the REPLACE study. There are many questions whether you need to use with CGM or with intermittently scanned CGM. You need to still use the finger prick method, the SMBG method. And the study gave a very clear reply: no, you don't. So this group was CGM only. This group was CGM with confirmations with blood glucose monitoring, as you can see. So the same initial results. And there is no difference whatsoever in the time in range, in hypoglycemia or in hyperglycemia. So you do not have to use SMBG in addition to CGM. CGM alone seems to be as good as if you do. And this is, of course, a very important message. And if you use a sensor without the need of calibration, you can completely eliminate the use of SMBG. Finally, it's the biological trial, if you want. It's a trial in pregnancy, this beautiful trial from Helen Murphy. What actually she did is, of course, she proved the A1C went down, but the time in range, as I mentioned, the significantly lower time in range during pregnancy normally was significantly improved, and biological outcome was the size of the babies, and the size of the babies was reduced, and the need of NICU was reduced. So a very important trial that I will show you later also actually resulted in cost saving. This is now the intermittently scanned CGM, or the Libre, the beautiful experience from the United Kingdom. They show that technology doesn't work in randomized controlled trials in the UK, the only country that doesn't work. But when they gave it to the people without physicians, it immediately worked, as you will see. So it seems like that the British physicians were the problem with technology, not really the British people with diabetes. And if you look at we did a study in the randomized controlled trial in children, and also actually show the same benefit as it's here. But if you look at this very recent, meta-analysis of British studies, you see that British people with diabetes are able to use beautifully the intermittently scanned CGM. And the higher the initial A1C, the better is the outcome. So my kudos to people with diabetes. They couldn't do it with the British diabetologist, but they could very well do it without. And this is just the three most important outcomes that you see here, actually. As you can see, this is mean A1C, this is adults, this is children separately, practically the same effect. So an immediate reduction of around 0.5%. And this is just the recent adoption data. As you can see, in the United States and Germany, all groups actually, they are around 40% penetration. So around 40% of people with type 1 at the moment are using CGM. I promised you a little bit on cost effectiveness. This is the national Belgium study. It was funded by the national insurance system in Belgium. And to their utmost surprise, actually, they were able to save, with all the costs of CGM, they were able to save €250,000 a year for 500 patients. So they calculated they will save a lot of money if they give CGM in Belgium. And of course, CGM is now reimbursed in Belgium. And from the pregnancy study, the British calculated if every pregnant woman in the United Kingdom would use actually the CGM during pregnancy, they would save 10 million pounds a year, 10 million pounds a year in money saving if every pregnancy was CGM guided. If we move a step further and we connect the two, actually, we get the closed loop. This is my city. If anybody is interested in a Middle European city, a castle from 11th century, a river, many old buildings. The city was established by the Roman Emperor Augustus in the year 4, and we still have Roman houses with mosaics if you want to see this. Why I'm showing it is because the first formal meeting for closed loop actually was held in Ljubljana in 2003. And then in 2005, the JDRF initiative started. So this is what we have on the market. This is the standard pump in our country, the 670G from Medtronic. The major message is the more it works in auto mode, the better is the outcome. It's not an ideal device, it's the first device, but it hands actually of people with diabetes, it works surprisingly well. This is actually the IQ technology that it will very likely be soon approved in the United States. And this is the last week publication, or 2 weeks ago, from the New England Journal of Medicine. As you can see, a beautiful improvement with this technology. And this was the one of the two that also deliver automatic boluses that I mentioned previously. And the time in range with this technology here, as you can see, this is baseline, and this is after half a year, and the time in range is above 70%, compared to CGM alone around 50. With this technology, you can come above 70%. This is another, if you want, kid on the block that's coming on the market. Again, very high, above 76% time in range. And there are the do-it-yourself people. I'm not sure they are present a lot in India, but in Europe it's growing. They are engineers mostly, very clever. They do their own closed loops, and they report very high success with them. But of course, this is not the general population. This is just the most educated engineers that can devise their own closed-loop systems. Lastly, this is the data from our NIH trial. It's called the Flair Trial, actually, and this is just 1 day of a person participating. And this is actually, this is automatic bolusing, so it's again the combination of automatic basal rate and automatic bolusing. And for this person, the time in range was 97% during the day. So you can, with this newest technology, really attain very high time in range percentages. And the automatic boluses in this particular child was above 30%. I would like to draw your attention to Tidepool. It's completely free possibility for download all your devices. It was financed by the JDRF in the United States. You can use it as hospital or as a private center or as a person with diabetes. And you can download any device on the market. So it's beautiful because you don't need many programs. You can just use one program to download all these devices. And in addition to this, you can use advisors that will do the analysis of the data for you. We did a small study, actually, to compare this device to physicians. As you can see, there is no difference between the physician and between this algorithm, between this artificial intelligence. So we suggest that this artificial intelligence, it's very quick. It only takes, less than a minute to do the calculation, can be another member of your team. The advisor also got the FDA clearance and the CE mark. So basically, it's legal to use it in the United States and the European Union. Another new thing is the connected pens. So this is just one example of them. They are connected via Bluetooth. You can also download them into Tidepool. And you get exactly the same download, actually, as with a pump. So for those of your people with diabetes that prefer a pen, a connected pen can be a very nice option. I know there is an Indian company also producing a kind of a connected pen, so you can have a local product. And again, for this, you can have a personal advisor to advise you on the dosing of insulin. Finally, the time in range. It was actually well known for years, and Arl Hirsch from Washington University was the first to say that a time in range of 7 may be actually, for some people, a mean glucose of 120, which is excellent, or for some people, a mean glucose of 190, which is terrible. So it's not really good on an individual basis. We did the first consensus 2 years ago, and we came actually out with a lot of measures. Too many measures, don't even read them. We couldn't do better at that time. So we actually did recalculations whether time in range is actually acceptable, and this is Roy Beck's and Rich Bergenstahl paper on the recalculation of DCCT data. This is the cohorts that you well know. And as you can see, the 50% time in range correlates really beautifully to the beginning of reduction. And if we take the 70%, people are really safe. So this is retinopathy, this is microalbuminuria. As you can see, below 5% and below 3% of people, if the time in range is 70, actually get these complications. So we did another consensus on time in range this year in Berlin. We put several questions to mathematicians. It was a very large preparation period of almost 4 months. And they calculated that if you have 10 days of data, the data become very stable. So you can very easily predict the dosing. So we decided that the 10 days of data, or 14 days if you want, of 70% of data is enough. And then we addressed the glucose variability. It's very difficult to present. This is Boris Kovachev's data. As you can see, too difficult for people with diabetes, too difficult for me as a healthcare professional. And then we actually found this David Rothbard data, and he showed that glucose variability is very tightly linked to the time spent in hypo. And this was repeated now in many studies and calculations, so we just decided to replace coefficient of variability by time below range, which is very easy to understand. And finally, the targets. We used several trials. We recalculated the data, and again found that 70% of time in range actually equals, in data, 7% of A1C. And this was repeated in several trials. This is the Roy Beck's data, and this is actually the Bob Vigurski data. Again, 70% roughly equals 7% of A1C. This was also true for type 2, surprisingly. The data is exactly the same and basically allows us to make these guidelines that you already saw, that were formally endorsed by the ADA, by the EISD, and by other professional organizations. And basically say for everybody now, the time in range, the new target between 70 and 180 should be above 70%. Not everybody can do it, but every 5% of increment makes a clinically significant difference. And time below range should be below 70, less than 1 hour, so quite a generous, I think, and it matches the physiological range of healthy people, as I mentioned previously, but below 54 should be below 1%, below 15 minutes, because this is away from physiology. We also limited, of course, time above range. More stringent for pregnancy, those of you that is interested, the graphical presentation, and importantly, the ambulatory glucose profile. This is respected now by all companies producing CGM, also by Tidepool and Gluco. Do we have new proof? So many studies are now ongoing that use time in range as a primary outcome. This is a recent one for the intima media thickness. As you can see, it's a beautiful correlation between time in range and the intima media thickness. And if you draw the line at 70, you actually get a normal intima media thickness in this population. And again, every improvement in time in range gives improvement in this clinical marker. So I'm suggesting to you a couple of conclusions. So number one, grade A evidence published that CGM works either alone or in closed loop. It improves control, it reduces hypoglycemia, it also, of course, improves quality of life. Time in range is a new management tool. Instead of looking back what happened 3 months ago with your A1C, every day you can at midday say, okay, my time in range is not yet 70, let's do something, it will be by the evening. So it's a prospective way of looking on diabetes, and you can improve yourself each time actually you look at it. Advisors can help and can speed up the process considerably, and I would like to draw your attention to the brain. The brain really suffers of high blood glucose, of hyperglycemia, and we all should do something actually to improve this. You're all invited to Madrid to ATDD meeting. It's actually all technology and new drugs, also NASH and other things will be discussed there. You're warmly welcome to join us in February 19 to 22. With this, I would like to thank you very much for your attention. These are the people that have to work while I speak. Thank you very much.
Thank you. The floor is open for questions, and a wonderful talk. You covered a lot of ground, and most important, brought us to where we should go forward. Excellent. Turn on the mic, please.
Yeah, you know, we had recently, there was a paper came out that CGMH is more important than putting on pumps or MDI. You know, there was some lot of came out articles on. So do you think there is any difference if a person is using only CGMS, well, you doing a CGMS, and using MDI or pump, does it make any difference in time and range?
Right.
In those patients, you know.
You're probably referring to the publication from Czech Republic in diabetes care. It's the Commissar study. And you can nicely grade. So if you are on MDI and you add CGM, you improve considerably. If you add a pump, you improve a little bit more. If you add both of them, you're at the best. So it's an increment of technology, basically, kind of a dose effect. The more you use it, the better is the final outcome. And as you saw, the time in range, if you use the closed loop, actually becomes the highest. So it's an increment. If you have to choose what's first, it's CGM. You know, this is a very good question, thank you. So number one, intermittently scanned CGM, or Libre if you want, is really a continuous meter. So when you download it, you get continuous data, like CGM. So it's the same. So you get all data. So Libre is basically a continuous meter. It just doesn't show it unless you want. But if you want, you can have a continuous data. Right. So the recommendation of 10 days is for physicians, of course. But for person with diabetes, actually, every hour counts. So if you have an intermittently scanned or a real-time CGM, every hour you can improve your time in range. And this is what we recommend, to use it prospectively. Okay? There is a paper from your Indian colleague from King's College London, Pratik Chowdhury. What he did is he calculated SMBG data from his cohort, and he showed exactly the same. So he calculated time in range with these people and showed the same effect. So if somebody is measuring a lot with finger sticks, you can even use this. And the paper was published in Diabetes, Obesity, and Metabolism.
And that actually, interestingly, was done retrospectively with the DCCT study, because they had data points, intensive 7 days every 3 months, at 7 points, and they calculate the time in range. So I really think the message is, while CGMS is good, if you do very vigorous SMBG and are motivated, you can achieve time in range and you can catch up. Like we have caught up this morning. We started late and we have caught up, and we are really ready to close this session, and thank you for a wonderful talk. There are some announcements which Dr. Rajiv Sinha will share with you regarding